Let's first talk about the power rule. So do you remember what we had from last time when we differentiate, and I said to remember, what did we get when we differentiated x to the third?
Would it be 3x squared?
That's it. So this is an example. Here is the rule, the power rule. X to any power differentiated. So again, we want to find a function that gives the slope of the tangent line or the rate of change, the instantaneous rate of change of this function at any point where it's differentiable. So what do you think I'm going to write? Can anyone try? Give it a try. What do you think?
Would it be nx to the power of n minus 1?
That's it. This is the power rule. So if I want to differentiate, for example, x to the 7th, what will I get? Who would like to give it a shot?
Would be 7x
7x to the 6th. What if I have now, let's say, 4x to the 3rd? And we have to discuss this before we continue. So if I have a constant times a function, and I differentiate this, the constant stays outside, and I have c times the function prime. Like we did with limits. If you remember, we had the limit of a constant times a function as x approaches a. What did we write for this one? Who remembers what does this equal to?
Would it be
c times the limit of f of x?
Very good, as x approaches a. Perfect. So the same thing here. The constant stays outside. We bring 3 in front, and we multiply by x to power 3 minus 1. And yes, we have to multiply. This is a factor that needs to be multiplied by 4, so this is 12x squared. This is not the distributive law. I'm not distributing 4 to 3 and 4 to x squared. This is just a product. This times this times this gives us 12x squared. So this is what we call the power rule. And then we're going to look at different problems. So if you'd like to open on page 145. And I'll tell you to pick whatever you want from 1 through 24. 1 through 24 on page 145. Not before I add one more concept here. Do you remember when we said that the limit of f of x plus or minus g of x under certain conditions, f and g have a limit as x approaches a? What did we say this was equal to? Anyone remembers the rule? Rita, do you remember the rule? Because I remember you asked me about that.
It's the same thing as limit of x to a f of x plus limit x to a.
Exactly, exactly. So this is the limit of f of x plus or minus the limit of g of x. Of course, when x approaches a, x approaches a. The same thing here. If I have a function plus another function prime, it's going to be the same thing. F prime plus g prime. You will also find in your book the following notation. Instead of f prime of x, you may find y prime, which is the same thing, or the derivative of y with respect to x. The derivative of y with respect to x, dy over dx. So all these mean the same thing. So then we differentiate a sum or a difference. It's like the limit. I differentiate the first function and then plus I differentiate the second one. So feel free to choose any problem from 1 through 24. If not, I will.
Do 19.
Okay, let's do 19. So 19 is y equals negative 4.8 times x to 1/3. This book, for some reason, is in love with rational exponents. So we are asked to find y prime or dy over dx. The constant stays in front. We have to bring 1/3 down, x, and now from 1/3 we have to subtract 1. What is the power? 1/3 minus 1.
Negative 2/3.
Great job, negative 2/3. So I will simplify because 4.8 divided by 3 is negative 1.6. So this is x to negative 2/3, and this is it. So if you're asking me, give me the rate of change of this function when x is 2, I will plug it in and give you the rate of change at that point. If you ask me, plug it in, tell me when x is negative 3, I will plug it in and tell you that. Good. Anything else, or we move on to the next set? 25 through anywhere you want. For now, 20, yeah, let's say 25 through 48. Any problem, so we can practice this? 25 to 48.
View 29.
29 it is. 29. I see it. So the derivative with respect to x of this function, that's another way of writing the same thing. Perfect. So this is a function minus a function plus a function. Fine, the same thing. So I have to differentiate the first one. Bring down 2, multiply by 5. So this is 10x. Differentiate negative 7. But when I differentiate x, so let me write this for you. X prime is 1. It's the slope of x. The slope of x is 1. And so this is minus 7. And when we differentiate a constant, any constant prime is 0. A constant doesn't have a rate of change. A constant is a number, and its rate of change is 0. So the derivative with respect to x of this function is 10x minus 7. Moving on, let's look at some radicals maybe, and some, yes?
Can you pause for just a second?
Yes,
How
of
did
course.
you get the 10x minus 7 again? Sorry, I didn't catch it the first time.
That's okay. So we bring down 3, we multiply by 4, and we subtract 1 from the power. I bring down 2, I multiply by 5, and I subtract 1 from the power. Is that
I
okay?
have another question.
Yeah.
Hold on just 1 second. Is that okay?
Oh, sorry.
Yeah, and then the negative 7, you just drop the x plus 3 here.
X prime is 1. 1 times negative 7 is negative 7. The derivative of a constant is 0.
Okay, I think that makes sense.
Oh, we need to practice. I mean, it doesn't click immediately. We need to be patient. Oh, absolutely. Very good question. Yes, sorry.
Oh, no, you answered it. Sorry about that.
No sorries. Very good. Okay, so let's choose something else. I'm on page 5. Next.
What are we choosing from?
anywhere between 25 and 48.
Can we do 27?
27. Yes. So 27, we have the derivative with respect to x of -2, the cube root of x to the fifth. So as I said, this book is in love with rational exponents. So let me refresh your memory. The nth root of a to power m is a power m divided by power n, the denominator n, the index n, not power, sorry, power index. So when I see the cube root of x to the fifth, I will change it into x to which power?
5/3.
Very good. So I will change it back in here. I'm continuing here. So this is the derivative with respect to x of -2 multiplied by x to the 5/3, 5/3. So now how do I continue? Can anyone give us this answer?
You multiply 5/3 by -2.
Very good.
Okay, and then you subtract 1 from the exponent.
Very good. Awesome. Great job. So -10/3 and x. And can anyone tell us 5/3 minus 1? How much is that? Not Rita. 2/3. Very good. Obviously, Lake is a master of fractions. Thank you, Lake. Very good. Okay, I think it's my turn to choose one. But I want to choose one that is not there because it's a very important one. So let's say I have f of x equals 1/x. Very important to remember. Please, to remember the derivative of this function. But I don't like the fact that it's presented as a fraction. Is there any way I can rewrite it without a fraction notation? Is there any way I could rewrite 1/x in a different way? Not as a fraction.
-1.
Well done. Thank you very much, Amanda. Yes, this is what I want. I don't want that. So then, when I differentiate x to -1, who can help here? It's the same thing. It's just that the power is a negative power now.
1x or just x?
The -1x?
So -1 multiplied by x. We haven't finished.
-1 minus 1 in the exponent.
Good, which is?
-2.
Very good, of course. So now this has to be changed back into a fraction. So how do I rewrite this?
-1/x².
Brilliant, thank you very much. So to remember, x to -1 or prime or 1/x prime, the same thing because these are the same. The answer is -1/x². This has to be carved in stone. Please. So we don't have to go through this, many times. Unless if we have to, we have to. We'll do it. But I'm hoping that moving forward, you understand the steps. Everyone, questions here?
Yeah, I have a question.
Go ahead.
On the previous question that we just did, why are we subtracting -1 in the fraction when we did like 5/3 minus 1? No.
I think she's showing you the in the formula you have to subtract 1. I had the same question and then looked back. If you look, it's m minus 1.
Oh, okay, okay. All right, thank you.
Sure. Very good. Okay, so I would like to choose 48, and then you can choose the next one. 48. 48 has y equals 2 over x minus x over 2. We are asked to find y prime. It's a difference of two different functions. That's okay. So y prime or dy over dx, same thing, different notation. This is called Leibniz notation. We're going to use it again later. You'll see why. So now we should always think when you see 2 over x, you should always imagine 2 times 1 over x. When you see x over 2, you should always imagine 1/2 times x. This is mandatory. This should be very clear. 2 over x is the same with 2 times 1 over x, and x over 2 is the same with 1/2 times x. So then, we want to differentiate this. Can anyone give us the derivative or the derivative function of 2 times 1 over x? Anyone?
I have an idea, but I don't know if it's the right first step.
It's okay.
Do we so the 1 over x is really x to the negative 1, right?
That's why we already did this. Let's not reinvent the wheel. We already have the derivative of 1 over x as negative 1 over x squared. This is done. So every time we see 1 over x, we don't think. We just remember it's negative 1 over x squared. I'm trying to be funny. Of course, we have to.
So then 2 just stays 2, right?
Correct.
Okay, and then times negative 1 over x squared.
Very good. Negative 2 over x squared. Perfect. And then I copy the minus. So let's differentiate this. What do we get? What is x prime? What does x prime equal to?
Square.
We wrote it down a minute ago. X prime is how much? How much is x prime?
It's 1.
Perfect. So this is negative 1/2. That's it. Very good. Okay, let's move on to 49 through 56. 49 through 56, anyone, or I pick?
We do 50.
50, very good. So 50. Any questions before we look at 50? So 50 is f of x equals x squared plus 4x and minus 5. There we are asked also to find f prime of 10. So what do we have to determine first?
The derivative.
Good. So can anyone give us the f prime of x?
Was it 1 that you said?
Say it again.
Was it 1?
F prime of x. F of x is x squared plus 4x minus 5. We have to determine f prime of x.
1x.
X plus 4.
So how do we differentiate x squared? What do we get when we differentiate x squared?
Yeah, x.
Which one? Say it again.
X.
Okay. X squared.
2x.
2x indeed. Good job. So that is 2x. And then plus
4.
4. We have the function that we are asked to evaluate at 10. So let's find f prime of 10. Can anyone give us f prime of 10?
24.
24.
Good. That's it. Okay. So
So that would be the slope at
exactly.
the x-coordinate of 10?
Exactly.
Huh.
So here's what it means. So let's suppose I have this graph. It's a parabola. It has a minimum. So let's say it's something like this. Of course, it has to have that shape. So let's suppose that this is x equals 10 right here. The rate of change of the function at that point is 24, which is the slope of this line. Rise over run. So this is 24 and this is 1. Exactly. Well done. I would like to, yes, any questions?
Yeah. Could you please explain how you got 2x plus 4 again?
So we have the formula. X squared is 2 times x to 2 minus 1.
Okay, so to find the is that how you find the derivative?
I have to because we are asked to find f prime of 10. I don't have the derivative. I have to find it first.
Okay, just making sure.
Good. Here it is, another problem. Let's say 6. Yes?
I have a question. So is this the exact same as the limit as h approaches 0 to the differential quotient?
Yes. So, but it's f prime of 10, which is limit, very good question, as age approaches 0 from f of 10 plus h. I replace x by 10 everywhere. Minus f of 10 divided by h. Exactly. So this is the x, in my case, is 10, and this is the x, and this is the x. So it should have been f of x plus h minus f of x, but specifically I'm told x is 10. So when I calculate this limit, the answer must be 24. But we don't no longer need this because now we have differentiation rules. We made our life much easier now.